All right, guys, part 2 of exponential function manipulation. I've got an equation up here where we're going to use some exponential properties to write this function in a different form. Now, it doesn't say what form to write it in, but eventually these questions will be multiple choice, and so it's kind of obvious how we're supposed to kind of change this at the end here. And then once we've done that, we're going to compare the graphs of both forms, so the original form and whatever we get at the end here. So yesterday we learned the product property, that if we're adding in the exponent, we could actually change that as multiplying like bases. All right, so we're going to have 2 to the x, and then multiply that with 2 to the third. Right, so this is the opposite of if we're multiplying like bases, adding the exponent. We're just doing that in reverse now. All right, so 2 to the x times 2 to the third. Well, now we could rewrite 2 to the third. 2 times 2 times 2, that's just 8. All right, so this is a different form. However, on a multiple choice part, the 8 would actually be listed first. And the reason we're going to list that first is now it's in a times b to the x form. All right, so this is what our answer would be right here. And again, you can't multiply the 8 with the 2. We can't make that 16 because they don't have the same, the same exponent for this question. Now, let's talk about the graphs of these two. So both of these are the graph of 2 to the x, right? 2 to the x, 2 to the x. This one has a plus 3. Well, that would just be the graph of 2 to the x, but then shifted left 3, right? We're adding with x, so it's going to move the graph to the left. Whereas this one, well, this is our value of a, and so it's multiplying the function. So this is a vertical dilation by a factor of 8. All right, so all I'm trying to point out with this, I'm not going to test you guys on if we remember the vertical dilation, horizontal dilation, all that stuff. But just recognizing these are equivalent, even though they're different transformations, that if you were to move this graph left 3, that would actually be the same thing as multiplying all the y values by 8. All right, so you could go through and try to graph it and see that those are the same. But again, that would take quite a while to do that. But it is interesting that, again, moving a graph left 3 when it's exponential growth is the same thing for this problem as just multiplying the y coordinates by 8. All right, a few more. We're going to use some exponential properties to write f of x in a different form. So we've got 9 times 3 to the x, and we can't multiply these, but I do realize that there's a way I could rewrite 9 that it's going to have a base of 3. Right, so we know that 9 is just 3 to the second. And the reason we write it as 3 to the second is now we can combine this because they both have the same base. So, and when we multiply like bases, we just add the exponent, so 2 plus x. Although most likely the x is going to be written first. So that would be the answer to this one. Next question, we're dividing. But kind of similar to the last one, 8 can be written as having a base of 2, just like 9 was written as having a base of 3. So we're going to write 8 as just 2 to the third, right? 2 times 2 times 2 gives us 8. Well, now we're dividing like bases. And if we're dividing like bases, we can subtract the exponents. All right, so that would be what we get when we, again, instead of dividing the bases, just subtract their exponents. So this is our alternate form here. And then lastly, we would need this one to be multiple choice to have really like more of an idea of how this is supposed to look. But one thing I could do to this, because 16 is a perfect square, I could write 16 as 4 to the second. And then it's all still raised to the x. All right, so I'm just rewriting 16 as 4 to the second. Well, now we have our power to a power property that if you're raising one exponent to another exponent, you actually just multiply the two exponents together. And this would be our alternate form right here. All right, so I know this is kind of weird. It's just taking an expression or an equation and writing it in a different form. But again, these will eventually be multiple choice, which will help us see kind of how the answer needs to end up at the end. All right, so that's it for this one, guys. Stay flawless.